Hi, this is Dr. JMR Chemistry. Today I would like to explain about iron. The symbol of iron is Fe. The symbol Fe comes from the Latin name of iron, that is ferrum. Iron is extracted from its ore, mainly hematite ore, that is Fe2O3, in a blast furnace. You know, the atomic number of iron is 56, then mass number is 56. Atomic number 26 and the mass number is 56. Then naturally iron show two type of valencies. Means we can call it as variable valencies. What is valency? Valency means the combining capacity of an atom of an element. What is variable valence? Means the ability of an element to show variable, means more than one valency in different compounds. We can call it as variable valencies. So iron show +2 as well as +3. If it is in the form of +2, we can call it as ferrous. If it is +3, we can call it as ferric. That is iron. We can write it as iron 2, iron 3. That is 2 and 3 show the valency of that element. So ferrous means low charge, that is Fe+2. Then ferric means Fe+3. Rus is low charge, Ric is high charge. Here iron atomic number is 26. Then naturally atomic number equals to number of electrons, means naturally it contains 26 electrons. So here what is electronic configuration? Now we would like to write electronic configuration. What is electronic configuration? Means distribution of electrons in various orbitals by increasing their energy levels. So here the lowest energy level is 1s. So that is why already I explained how to write the electronic configuration in previous videos. So here first electrons enter into 1s2, first orbit, next 2s2, 2p6, 3s2, 3p6, 4s2, then 3d6. Means 26 electrons distributed in 4 orbits. 26 electrons distributed in s, p, d orbitals. So electrons are generally will write in superscript, that is 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 6. Total 26 electrons. So like this, nucleus contains, this center contains protons as well as neutrons. So electrons are present in the outermost shell, means shells. Orbit contains what? Orbit contains electrons. That center contains neutrons and protons. Electrons are revolved around the nucleus in a closed and fixed circular path. Generally, only electrons will take part in the chemical bond formation, not protons and neutrons. Then here, what is orbit? Very important terminology. What is orbit means? Electrons revolve around the nucleus in a closed circular path. That path is known as orbit. See here, this is first orbit. Contains here 2 electrons like this first orbit. Second orbit, this is 2 and 2. It contains 6 plus 2. Total 8 electrons like this 1, 2, 3, 4, 5, 6, 7, 8. And third orbit contains 14 electrons. So you see here like this. So 2 plus 6 plus 6, 14 electrons. And here valency shell contains only 2. That is fourth orbit contains 2 electrons. So valency shell contains 2 electrons like this. So why sometimes you'll get one simple doubt. What is that? After 2p electrons enter into 3d, why not after 3p electrons enter into 4s instead of 3d? What is the reason behind that? I explained in a previous video. Please go through that. So here first orbit contains 2 electrons, second orbit 8, and third orbit contains 14 electrons, and here second orbit contains 2 electrons. So I explained about SPDF orbitals in previous videos. Please go to that. So here generally valence shell or valence electrons will take part in the chemical bond formation. See here, this is the valency shell or outermost shell. So here S contains only 2 electrons, P contains 3 degenerate orbitals. They are Px, Py and Pz. And 4s contains only one degenerate orbital, and d orbital contains 5 degenerate orbitals. Degenerate orbitals. What are degenerate orbitals? Orbitals having same energy but differ in their orientation. I explained in previous videos regarding orbitals. So like this, S contains 2 electrons, then P contains 6 electrons, then S contains 2, then D contains 6 electrons. Means first 1, 1, 1, 1, 1, then pairing of electrons takes place according to Ohm's rule. It contains 4 unpaired electrons in the valence shell. Is it stable atom? No, it is unstable. Why? Because it contains unpaired electrons. They are ready to what you call form a bond with another atom. So that's why it is unstable. And if you want to write electronic configuration of ferrous, there's iron 2. Iron 2 means what? It contains 24 electrons. Why? You have to remove 2 electrons from iron. Iron contains 26 minus 2. Means you have to remove 2 electrons from iron. Then you will get ferrous Fe plus 2. It contains 24. Then write the electronic configuration means you have to remove 2 electrons from where? From 4s orbital. So now you remove 2 electrons from 4s, not from 3d. Why? Fourth is the valency shell, outermost shell. Suppose you take 4th class student, you have to remove from what you call 4th class student, after the 3rd class. So that's why you have to remove 2 electrons from outermost shell. That's 4th is the outermost shell. Then here, yes, like this. So remove 2 electrons from 4s. There is the electronic configuration of Fe ferrous. 3s2, 3p6, 3d6. Isn't it? That is 1s2, 2s2, 2p6 is common. So here you have to remove. Yes. Like this, The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. It contains how many electrons? Total 24 electrons. Suppose if it is ferric, that's iron 3. Then iron minus 3, that is nothing but 23 electrons. Iron minus 3, you will get Fe plus 3. Means you have to remove 3 electrons. You will get 23. Then you have to remove one more electron. Where? From 3D. So previously you removed 2 electrons from 4s. It is converted into ferrous. Again you have to remove one more electron from ferrous. Where? From 3D. So like that, Fe minus 3 electrons, you will get Fe plus 3. So what is the electronic configuration? So like this, 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. This is the electronic configuration. So among these three, which one is more stable? Simple. Ferric is more stable. Why? It contains all unpaired electrons. According to Hund's law of maximum multiplicity, half filled or completely filled orbitals are more stable. So that's why Fe plus 3 is more stable. So here, iron contains 26 electrons. You are by removing 2 electrons, that is 24 electrons, means iron ferrous or iron 2 contains 24 electrons, and here ferric contains 23 electrons. So like this, and here ferric is more stable. The electronic configuration of Fe 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d6, and here ferrous is 1s2, 2s2, 2p6, what is that? 3s2, 3p6 and 3d6. Then if it is ferric, 1s2, 2s2, 2p6, 3s2, 3p6 and 4, 3d5. Like this here. This is very, very important concept. Now we'll see how this ferrous ion and ferric ion in the formation of a compound. You take ferrous ion, that is Fe plus 2. Then chloride, you take Cl minus 1. By using crisscross method, then 2 will come here, then 1 will come here. Then it is nothing but FeCl2, ferrous chloride or iron 2 chloride. Iron 2 chloride or ferrous chloride. Then ferrous chloride is formed when iron react with dilute HCl or you take limited supply of chlorine. Here ferrous chloride is formed. So that is in the form of +2 oxidation state. Similarly, you take ferric chloride. Ferric means Fe plus 3, then Cl minus, chloride, that is Cl minus 1. By using crisscross method, FeCl3, then iron 3 chloride or ferric chloride is formed. Like this here, what happened? When ferric chloride is formed, iron react with excess of chlorine. Excess of chlorine, naturally you will get a ferric chloride. So like this, if it is in the form of +3 oxidation state. So like this, ferrous and ferric so plays a major role in the formation of the respective compounds. So like that. Thank you. Thank you very much. This is Dr. JMR Chemistry.